All right, so as we continue on numbers 9 through 18, finding the GCF of each pair of numbers, I'm going to go ahead and get a scratch piece of paper for this to allow room to write the numbers. All right, so the greatest common, or the factors of 40 are 1 and 40, 2 and 20. We know 3 is not, because 4 plus 0 is 4, and 4 can't be divided by 3. So if 4 can't be divided by 3, 40 cannot be divided by 3. 4 is a factor of 40. 5 is a factor of 40 because we know that 40 ends in a 0 or a 5, and any number that ends in 0 or 5 can be divided by 5. Right? 6 is not a factor of 40. 7 is not a factor of 40. Right? So these are our factors of 40. 48. Well, we know 1 and 48. We also know 2 and 24 are factors of 48. 3 is a factor of 48. 4 plus 8 is 12. And 12 can be divided by 3. If 12 can be divided by 3, 48 can be divided by 3. And that's 3 times 16. 4 is a factor of 48. 4 times 12. 5 is not a factor of 48. It doesn't end in a 5 or 0. 6 is a factor of 48. Again, I see that 2 and 3 are both factors of 48. So 6 is also a factor of 48. And that's 6 times 8. 7 is not. 8 we already know. 9 is not. So these are our factors of 48. So circle our common factors. And we see that 8 is our greatest common factor. Right? Number 10, 30 and 45. Right? 1 and 30, 2 and 15. Again, we know 2 is a factor of any number that is an even number. 3 is a factor of 30, 3 times 10. 4 is not a factor of 30. 5 we know is 5 times 6. 7 is not a factor of 30, nor is 8. And 9 is not a factor. 45, 1 and 45. 2 is not a factor of 45. Does not end in a 5. Is not an even number. 3 is. 4 plus 5 is 9. 9 is divisible by 3. So 45 is divisible by 3. 3 times 15. 4 is not a factor of 45. 6 is not a factor of 45. 7 is not a factor of 45. 8 is not. 9 is. 9 times 5. All right, so our factors of in common are 1, 3, 5, and 15. So our greatest common factor is 15. Number 11, 10 and 45. So the only factors of 10 are 1 and 10 and 2 and 5. Factors of 45, we just listed those. So let's write them again. 1, 3, 5, 9, 15, 45. 1's in common, 5's in common. So the greatest common factor of 10 and 45 is 5. Okay, greatest common factor of 25 and 90. 1 and 25. 2 is not a factor of 25. 3 is not a factor of 25. 5 is. Okay, those are the only factors of 25. 1, 5, 25. Factors of 90 are 1 and 90. 2 and 45. 3 and 30. 5 and 18. 6 and 15. And 9 and 10. Common factors are 1, 5, 1 and 5. So the greatest common factor of 25 and 90 is 5. 13, we have to find the greatest common factor of 21 and 40. 1 and 21, 3 and 7, 1 and 40, 2 and 20, 4 and 10, 5 and 8. Greatest common factor 1. Greatest common factor of 21 and 40 is 1. 28 and 70. Okay. So 28 and 70, the common factors are 1 and 2, 7, and 14. So the greatest common factor is 14. 15, 60, and 72. All right. So the the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. 72, 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. Circle all the common factors. Greatest common factor is 12. Okay, and number 16, we have to find the greatest common factor of 45 and 81. All right, we know 1 and 45 are factors of 45. 2 is not. 3 is. 4 is not. 5 is. 5 times 9. 6 is not. 7 will not work. And 8 will not work. 81. 1 and 81. 2 is not. 3 is. 3 times 27. Again, I knew 3 is a factor because 8 plus 1 is 9. 9 can be divided by 3. Okay, 4 is not. 81 is not even. 5 will not work. 6 will not work because 2 is not a factor of 81. 7 will not work. 8 will not work, but 9 will. So our factors in common are 1, 3, 9. Okay, so the greatest common factor is 9. (17). We have to find the greatest common factor between 28 and 32. Okay, will 3 work? No, because 8 plus 2 is 10. 10 is not divisible by 3. 4 is, because 4 times 7 is 28. 5 will not work. 6 will not work. And we already know 7 will. 8 will not work. 9 will not work. 32, 1, and 32. 2, and 16. Will 3 work? No. 3 plus 2 is 5. 5 is not divisible by 3. 4 will work. 4 times 8. 5 will not work, does not end in 0. 6 will not work, it's not divisible by 3. 7 will not work. 8 we already know works, and 9 will not. So our common factor is 1, 2, 4. Okay, so the greatest common factor is 4. And 18, the greatest common factor of 55 and 77. Factors of 55, 1 and 55. 2 is not a factor, is not an even number. 3 is not, because 5 plus 5 is 10. 10 is not divisible by 3. 4 will not work, it's not an even number. 5 will work, 5 times 11. 6 will not work, because 2 and 3 are not factors of 55. 7 will not work, 8 will not work, 9 will not work. These are the only factors of 55. 77, 1 times 77. 2 will not work, it's not even. 3 will not work because 7 plus 7 is 14. 14 is not divisible by 3. 4 will not work because it's not an even number. 5 will not work, doesn't end in a 5 or 0. 6 will not work because it's not divisible by 2 and 3. 7 will work, 7 times 11. 8 will not work, nor will 9. So the factors in common are 1 and 11. So our GCF is 11. All right, 19. All right, Carlos is arranging books on shelves. He has 32 novels and 24 autobiographies. Each shelf will have the same number of novels and autobiographies. If Carlos must place all of the books on shelves, what are the possible number of shelves Carlos will use? So basically that question is asking us, what are the common factors of 32 and 24? All right, so let's do that. 32, 24. So we know 1 is in common. I'm sorry, is a factor of 32, 1 and 32. 2 and 16. 3 is not a factor of 32. 4 is. 5 is not. 6 is not. 7, 8 we already know. 9. So those are our factors of 32. 24, 1 and 24. 2 and 12. 3 and 8. 4 and 6. 5 is not. We already know 6 is. 7 is not. 8 we already know is a factor of 24, and 9 is not. So common factors of 32 are 1. Common factors of 32 and 24 are 1, 2, 4, 8. So we could have 1 shelf, 2, 4, or 8 shelves. All right, number 20. The middle school band has 56 members. The high school band has 96 members. The bands are going to march one after the other in a parade. The director wants to arrange the bands in the same number of columns. What is the greatest number of columns in which the two bands can be arranged if each column has the same number of marchers? How many marchers will be in each column? So again, that's asking us to find the common factors between 56 and 96. 1 and 56. 2 and 28. 3 is not a factor of 56. Again, we know 6 plus 5 is 11. 11 can't be divided by 3. 4 is a factor of 56. 4 times 14 is 56. 5 is not. It doesn't end in a 5 or 0. 6 is not because it's not divisible by 2 and 3. 7 times 8 is 56. 9 will not work. All right, so those are our factors of 56. 96. We know 1 and 96. We know 2 and 48. 3 is a factor of 96. 3 and 32. 4 is a factor of 96. 4 and 24. 5 is not, but 6 is. Okay, again, I knew 6 is because it was also factors of, it also has factors of 2 and 3. 7 is not a factor of 96. 8 is a factor of 96, 8 times 12. 9 is not a factor of 96. All right, so our common factors are 1, 2, 4, 8. Okay, 1, 2, 4, and 8. The greatest number of columns would be 8 columns. So there'd be 7 and 12. So there are going to be 7 middle school members. And there will be 12 high school members. Okay, because 8 times 7 is 56 and 8 times 12 is 96. Not members, but marchers. All right, 21. For football tryouts at a local school, 12 coaches and 42 players will split into groups. Each group will have the same number of coaches and players. What is the greatest number of groups that can be formed, and then how many coaches and players will be in each of these groups? So we have to find the greatest common factor of 12 and 42. Well, the factors of 12, 1 and 12, 2 and 6, 3 and 4. Factors of 42, 1 and 42, 2 and 21, 3 and 14, 6 and 7. Okay, so we could have 1, 2, 3, 6, the greatest number of groups that can be formed is 6 groups. Two coaches in each group. Seven players. All right, 22. Lola is placing appetizers on plates. She has 63 spring rolls, 84 cheese cubes. She wants to include both appetizers on each plate. Each plate must have the same number of spring rolls and cheese cubes. What's the greatest number of plates she can use using each of the appetizers? And how many will be of each? Okay, again, we're finding the greatest common factor. 63, 84. All right, 1 and 63. 2 is not a factor of 63. 3 is. 3 and 21. 4 is not. 5 is not. 6 is not. 7 times 9 is 63. Okay, so those are our factors of 63. 1 and 84. 2 and 42. 3 and 28. 4, and 21. 5 is not a factor. 6 is a factor. 6 and 14. 7 is not. 8 is not. And 9 is not. All right, so 1, 3, 21. Okay, so the greatest number of plates she can make is 21 plates. And she'll have 3 spring rolls, and 4 cheese cubes. All right, page 36. All right, so we're going to rewrite these. Write the sums as numbers of their products and their GCF and another sum. All right, so 23, 56, and 64. We have to find the greatest common factor of 56 and 64. So the factors of 56 you should have come up with was 1, 2, 4, 7, 8, 14, 28, 56. 64. Okay. For 64, you should come up with 1, 2, 4, 14, 32, 64. So if we circle all the common factors, we find that 14 is the greatest common factor. So we can rewrite 56 plus 64 as 14 times 4 plus 14 times 4. Oh, no, I'm sorry. I'm looking at this. 4 times 14 is not 64. 4 times 14 is 56. So 4 times 16. So 14 is not in common. But 8 times 8 is 64. I overlooked 8 times 8. All right, so scratch that. All right, so the greatest common factor is 8. That makes a little more sense to me. So 8 times 7 plus 8 times 8, which can be rewritten as 8 times the sum of 7 plus 8, which is the same as saying 8 times 15. So, all right, 14, 24, 48, and 14. All right, find the greatest common factor of 14 and 48. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Okay, so those are the factors of 48. Factors of 14, 1, 14, 2, 7. Common factors are 1, 2. Okay, so the greatest common factor is 2. So 2 times 24 plus 2 times 7. We rewrite that as 2 times the sum of 24 plus 7. Okay, again, the greatest common factor of 24 and 7 is 1, so I know I found the greatest common factor. Okay, 25. Find the greatest common factor of 30 and 54. One and 30, 2 and 15, 3 and 10, 5 and 6. 54, 1 and 54, 2 and 27, 3 and 18, 6 and 9. Common factors are 1, 2, 3, 6. Okay, so we can rewrite this as sum of 6 times 5 plus 6 times 9, which is the same as saying 6 times the sum of 5 plus 9. (26). We have to find the greatest common factor of 24 and 40. One and 24, 2 and 12, 3 and 8, 4 and 6. 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. Okay, factors in common: 1, 2, 4, 8. Greatest common factor is 8, so 8 times 3 plus 8 times 5. Again, we're finding greatest common factor is 8. 8 times what is 24? 8 times 3. Greatest common factor is 8, so 8 times what is 40? 5. And we can rewrite that as 8 times the sum of 3 plus 5. (27). All right, so the greatest common factor of 55 and 66 is 11. So we can rewrite 55 as 11 times 5, and we rewrite 66 as 11 times 6, which is the same as saying 11 times the sum of 5 plus 6. (28). we're going to rewrite 49 plus 63. Okay, the greatest common factor of 49 and 63 is 7. So we write that as 7 times 7 for 49 plus 7 times 9 for 63. So using strict recovery, we write that as 7 times the sum of 7 plus 9. So 7 times the sum of 7 plus 9, which is the same as saying 7 times 16. All right, number 29, 40 plus 25. Okay, 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8. 25, 1 and 25, and 5 times 5. So the greatest common factor is 5. So we're going to rewrite 40 as 5 times 8. And we're going to rewrite 25 as 5 times 5. And rewrite that as 5 times the sum of 8 plus 5. And 63 and 15. Okay, the greatest common factor between 63 and 15 is 3. So 3 times 21. 63 can be rewritten as 3 times 21. And 15 can be rewritten as 3 times 5. Which is the same as saying 3 times the sum of 21 and 5. Explain why the greatest common factor of two numbers is sometimes 1. Well, not all. Well, okay, so we know 1 is a factor of all numbers. We also know that some pairs of numbers only have 1 in common. Okay, all right, so how come 1 is sometimes the greatest number? Well, because 1 is a factor of all numbers, right? But some pairs of numbers only have 1 as a common factor. Like if we said find the greatest common factor of 3 and 11. Well, the only factors of 3 are 1 and 3. The only factors of 11 are 1 and 11. So the only thing in common is 1. All right, 32. Tasha believes that she can rewrite the difference, 120 minus 36, as a product of the GCF of the two numbers and another difference. Is she correct? Yes. All right, so if we wrote 120 and we wrote 36 and we wrote the common factors, right? It's the same thing as finding the greatest common factor of two sums, except we're just doing subtraction this time. So 120 would be 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 15, and 10 times 12. And 36 okay, 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Common factors are 1, 2, 3, 4, 6, 12. Okay, so we can rewrite that as, we can rewrite 120 as 12 times 10 minus, how do we rewrite 36? 12 times 3, which is the same as saying 12 times 10 minus 3, which is 12 times 7. All right, 33. Explain how to find the greatest common factor of three numbers. Well, we've got to find the factor of all three numbers. And the greatest factor in common. For example, 4, 8, 12. So in 4, 8, 12, we list all the factors of 4, 1, 2, 4, 8, 1, 2, 4, 8, 12, 1, 2, 3, 4, 6, and 12. Circle anything in common, and we see that 4 is the greatest common. So same as two numbers, except we just have the third. All right, Zhao's teacher, I think it's Xiao's teacher, asked him to rewrite the sum 60 plus 30 as the product of the greatest common factor of two numbers and a sum. Xiao wrote 3 times 20 plus 30. What mistake did he make? How should he have written this up? Well, when I look at 20 plus 30, the greatest common factor between those two is not 1. So he didn't find the greatest common factor. 3 is not the greatest common factor. So I know that 10 is the greatest common factor of these, right? 10 times 2 is 20. 10 times 3 is 30. So he should have pulled out an extra factor of 10. So 10 times 3. So he should have written it as 30 times 2 plus 3. All right. So that's it for finding the greatest common factor. In our next lesson, we'll be working with finding the least common multiple.